Hello everyone. So welcome to all for this lecture. In this lecture, I'm going to explain what do you mean by sequential circuits and what is clock signal and different types of recurring in clock signals. Okay, so this is what we are going to discuss in this lecture. So first, we'll start from the sequential circuits. So before going to see the sequential circuits, first I would like to explain the digital circuits. It is classified into two types. One is combinational circuit, another one is sequential circuits. So in combinational circuits, the output is depends upon only the present input. Okay, but in sequential circuit, the entire circuit is called a sequential circuit. In sequential circuit, the output is depends upon input as well as the past output. So past output is here called as a previous state or present state. It is simply represented as PS. So combinational circuit, the output is depends only present input, and sequential circuit, the output is depends upon present input as well as the past output. Okay, so to remember the past output, we are in need of a memory device in sequential circuits. Okay, so this is what the introduction about the sequential logic. It is consist of a set of inputs and outputs, and the outputs of a sequential circuit depends not only on the combinations of present input but also on the previous output. Okay, so the previous output is nothing but it is a present state. We can represent this as simply PS, right? Therefore, the sequential circuits contain combinational circuits along with memory elements. Yes. Some sequential circuits may not contain combinational circuits but only memory elements. Yes. So we can represent these sequential circuits in a two way. One is including this combinational circuit, another one is without including this combinational circuit. So we can design in any way. Okay. But if a sequential circuit means it should consist of only this combinational circuits plus memory. Memory is very, very important. Without memory, we can't be able to design the sequential logic. Okay. So sometimes combinational circuits will come, sometimes it won't come. But memory is permanent one in sequential logic. Okay, fine. Next, so first I would like to explain the differentiation between combinational and sequential circuits. So have a look at the first differentiation. Output depends only on present input. This is the definition of combinational circuit. Output depends on both present input as well as the present state or past state or previous state. Okay, so this is the definition about sequential circuits. Then feedback part is not present. Yes, output is depends only present input, so the feedback part is not needed. So here the example is gates or the examples for these combinational circuits, and here the feedback part is present. Yes, memory is needed because it depends upon the present state also. So here the example is flip-flops, and here memory elements are not required. Yes, and here memory elements are required. Yes, and clock signal is not required, and here the clock signal is required because here we are using memory it won't work without this clock signal. Okay, and this is easy to design and this is very difficult to design because it is consists of some feedback part, so the design is somewhat difficult compared to this combinational circuits. So these are only some of the differentiation between combinational circuits and sequential circuits. Okay, fine. So the next thing is the types of sequential circuits. So the sequential circuits are classified into two types. One is asynchronous sequential circuit, another one is synchronous sequential circuits. So what is the differentiation between this asynchronous and synchronous? Okay, so in both asynchronous and synchronous, we are going to use a multiple number of memory devices. Okay, so as we know that memory devices are working with clock signal. Okay, so here I am going to explain the differentiation between these two with the help of clock signal. That is, in asynchronous sequential circuits, see, if multiple memory devices are connected together, that is the output is connected to the input, output is connected to the input. Okay, so each and every devices we need to provide the clock signal. Okay, so this is clock and this is input. Now I am explaining about the asynchronous. So for the first device, this is first flip-flop, second and third flip-flop. For the first flip-flop, we are giving clock signal here. But for the second flip-flop, this output of the previous flip-flop will be given as a clock, and for the third one, second flip-flop output will be given as a clock. So the first device only driven by the clock signal, the second and third flip-flops are driven by the previous flip-flop output, which means all the devices will not work at the same time. Okay, so it depends upon this output, the corresponding flip-flops will work. This is what asynchronous. But in synchronous, it is not like that. So in synchronous, whatever number of the flip-flops we connected together, for all the devices we are going to apply the clock pulses separately. See, I'm going to apply the separate clock signal for this. Okay, so here all the flip-flops are going to work at the same time because we applied clock signals separately, that is individually to all the flip-flops. So this is the difference between the asynchronous and synchronous sequential circuits. Let's we'll see one by one. First one is asynchronous sequential circuits. Have a look at this. The input is applied. Here the JK flip-flop is taken in all the three flip-flops. This is 1, 2 and 3. See, clock signal for the first device only we have applied clock signal. The second flip-flop for clock signal is from the first flip-flop output, and the third flip-flop for clock signal is from the second flip-flop output, which means all the flip-flops are not working at the same time. Have a look at the explanation. All the outputs of a sequence circuit do not change affect with respect to the active transition of clock signal. Then the sequence circuit is called as asynchronous sequential circuits. Okay, that means all the outputs of asynchronous sequential circuits do not change affect at the same time. This is very, very important. Okay, all the three flip-flop output do not changes at the same time because of this clock signal. Okay, so see here positive edge clock signal is given. Positive edge means here there is no bubble, and here also no bubble, here also no bubble. So positive edge means whenever this output is 1, that time only it will work. If it is 0, then this flip-flop it won't work. Okay, that's why here it is telling that circuits do not change affect at the same time. Right. So most of the outputs of the asynchronous sequence circuits are not in synchronous with either only positive edges or only negative edges of clock signal. Yes, this is what the introduction about asynchronous sequential circuit. Now, synchronous sequential circuit. Have a look at this. JK flip-flop is taken here, and the low level clock signal is used here. See, clock pulse simultaneously applied here first one, and here second one, and here third one. So for all the three flip-flops, the clock pulse is applied simultaneously. Okay, see, so sequence circuit change affect with respect to the active transition of clock signal, then that sequence circuit is called as synchronous sequential circuit. Yes. So the output of the synchronous sequential circuits change affect at the same time. So here it is working at the same time because all the devices are connected with individual clock pulses. Okay, right. The next one is clock signal and triggering. What do you mean by clock signal, and how to apply the triggering to the devices? So first, so clock signal is a periodic signal, and its on time and off time need not be the same. Yes. So we can represent the clock signal as a square pulse. See, this is the square pulse. So this on time and off time will not be the same. This is a high level, that is on, and this is low level, that is off. So the time period, see, this is the time period. These two time period need not be the same one. Okay, sometimes on time maybe it is 3 seconds and off time is 2 seconds. Okay, otherwise sometimes this is 3 seconds, this is 3 seconds. Sometimes it will be same, and sometimes it will not be the same. Okay, then there is no conditions, both on time and off time should be the same. Okay, right, need not be the same. Right, so we can represent the clock signal as a square wave. Yes, when both its on time and off time are same. Yes, the clock signal is shown in the following figure. Have a look at this. This is a clock signal, and this is on, and this is off, and this is one clock signal time period. Okay, for a single clock signal it consists of both on and off. So each and every clock signal, one on time will be there, one off time will be there. So the low level represents 0 volt and high level represent 5 volt, the maximum applicable voltage level for the digital circuits. Okay, so this is what the representation of clock signal, right? So we can represent the clock signal as a train of pulses when on time and off time are not the same. The clock signal is shown in the figure. See, this is the width is very high, and here width is very low. So on and off time are not same. This is the example. Okay, the previous one is for the same level. This is the example. Here two are same. See, on time and off time are same. This is the example, and this is for not same. This is the example. Okay, so I hope all you guys can understand. Fine. So types of triggering. There are two types of triggering is there. One is level triggering, another one is edge triggering. Let me explain. So level triggering and edge triggering. So in clock pulse, see. So this is called as level, and this is also called as level. Okay, so level means it is same position. That is what level. Okay, so this is a positive level and this is negative level. Okay, let me explain detailedly in the next slides. And edge triggering means, so what do you mean by edge? Edge means it is only one place. Okay, see, this is rising edge. This place is rising edge because it is changing from low to high. Okay, so this is called as rising edge, and this place is called as, that is, this is called as edge. Okay, this place is called as edge, and it is changing from, this is high and this is low, so changing from high to low, so this is called falling edge. So this is a rising edge and this one is falling edge. Okay, so this is what level triggering and edge trigger. So level means one entire level, all the values are same. Edge means at one point of, we can call it as an edge. See, when it is changing from one position to another position, that point is called as edge. Okay, fine. So first I will talk about the level triggering. So there are two levels, namely high and logic low in clock signal. Following are the two types of level triggering. Yes, just now I have explained. So positive level triggering and negative level triggering. So this is a positive level triggering and this is negative level triggering. Okay. And positive level triggering. See, if the sequential circuit is operated with the clock signal when it is in the logic high, then that type of triggering is known as positive level triggering. Yes, when we are applying only positive level, that is a high level signals, if we are applying, then that is belongs to positive level triggering. Have a look at this picture. See, here the top side is, in each and every clock pulse it is highlighted because this is a positive level triggering. Okay, and see, this is our flip-flop. So here I am going to give the clock signal is positive level signal, that is a high level triggering. Okay, right. And negative level triggering. Sequential circuit is operated with a clock signal when it is in the logic low. It is called as negative level triggering. And have a look at this picture. The low level is marked in all the clock signal. Okay, this is what low level triggering. And see, here I am going to apply this low level signal, and this is a flip-flop. So each and every flip-flop, so 5 signals are must. Okay, that is input, output, and this clock one. Then here clear. These 4 signals are very important in all the sequential circuits. Without this 4 signal, it will not work. Okay, right. So I hope you guys are understanding regards level triggering, positive level and negative level. Now edge triggering. So there are 2 types of transitions that occur in clock signal. That means the clock signal transition either from logic low to logic high or logic high to logic low. Just now I have explained. No, see, this point is called as this is logic low and this is logic high. So at this point the values are changing. Okay, and similarly this is high and this is low. At this point the high is changing to low. So this point is called as rising edge and this point is called as falling edge. Okay, so here two types of triggering is there. One is positive edge triggering, this is positive edge triggering, and this is negative edge triggering. Okay, right, positive edge triggering and negative edge triggering. Fine, what do you mean by positive edge triggering? Operated by the clock signal, that is transitioning from logic low to logic high, that is called as positive edge triggering, and it is also called as a rising edge triggering. And we have a look at the pictorial representation. See, this places this line is called as positive edge triggering, and for a flip flop I am going to apply this positive edge triggering as a clock signal. Okay, similarly negative edge triggering is quite opposite to the positive edge triggering, transitioning from a logic high to logic low, then that type of triggering is called as negative edge triggering. And it is sometimes it is called as it is always called as a falling edge triggering. Okay, have a look at this picture. See, each clock pulse one negative edge triggering will be there. So this is what I am going to apply for my clock signal. So negative edge triggering means here bubble symbol will be there. That is very important. See the previous one. So here there is no bubble, which means this is positive edge triggering. Okay, if there has been a bubble, then that is called as negative edge triggering. Similarly, in level triggering also, positive level here there is no bubble, negative level there will be a bubble will be there. Okay, fine. So finally the differentiation between level triggering and edge triggering. See, the first one is edge triggering, the type of triggering that allows the circuit to become active at the positive edge or the negative edge of the clock signal. Yes. So it will be active when the clock pulse is in the particular level, whether it is in a positive level or negative level. Next, an event occurs at the rising edge or falling edge. Yes, the output will be changed only at the rising edge or falling edge. Here, only high level or low level. Okay, it will not be changed. The output will not be changed at the time of changing from high to low or low to high. Once it reaches the high level, then only it will be changed. Okay, so here the flip flops are edge trigger, and here the latches are level trigger. Okay, so these are the differentiation between level triggering and edge triggering. Yes. So let me conclude quickly. So in this lecture we have been discussed what do you mean by sequential circuits and the differentiation between combinational as well as the sequential circuits. Okay, then the types of sequential circuits, asynchronous and asynchronous sequential circuits. Then clock pulse and the two types of triggering, positive triggering, that is a level triggering and edge triggering. In level triggering, two types, positive level and negative level. And the edge triggering, again it is two types of positive edge triggering and negative edge triggering. Hope you guys are understand the concept of the sequential logic circuits. See you in the next lecture with some different topics. Thank you.